Wait. All of you are audible?
Yes, sir.
All of you have
Yes,
seen
sir.
the screen. Screen is visible.
Yes, sir. Yes, sir. Yes, sir.
Can I start?
Yes, sir.
Yes, sir.
Okay. Welcome again to the new lecture, that is wind. Very important aspect, very important weather element related to the agricultural business, related to the biosphere. In the scene, in the first lecture, that is the earth has the four sphere, that is, one is the lithosphere, hydrosphere and atmosphere, and all three is interrelated to the biosphere. Biosphere means all the living entities in the biosphere. So regarding to this, wind is a very important aspect, very important phenomenon related to the agriculture, related to the life. So causes of wind generation or causes of the formation of wind. That is, one is the difference in temperature over the earth surface. Temperature, pressure and wind are related to the each other. High temperature is equal to means low pressure and vice versa. Already we have seen. At a low temperature, density of air is high and vice versa. This sentence is very important. Temperature if low, then density of air is high. Temperature is high, density of air is low. Then what is mean by wind? In general, air in motion is called as the wind. जो हवा बहती है उसको क्या कहते हैं? वारा. वारा को क्या कहते हैं श्रेया हिंदी में? विंड को?
फॉग सर.
हाँ?
विंड को सर, विंड को हिंदी में पूछ रहे हैं?
हाँ.
सर हवा, हवा कहते हैं.
It is synonymous word is very difficult. Marathi and Hindi hawa and wind is different. Okay.
Okay.
The
Okay, sir.
parallel to the motion of the air. Air means hawa. Okay. Wind को क्या कहते हैं मुझे नहीं आता है कि sorry for that. Okay. So horizontal flow of air is called as wind. And wind results from the pressure gradient. Already we have seen in last lecture the change in the place and change in the pressure is called as the pressure gradient. Means as changing the place, changes in the pressure is called as the pressure gradient. The flow of wind is from high pressure to low pressure. Wind plays important role in making of weather. The weather phenomenon, how is the weather, is basically based on the wind. So which forces are generating the wind are the responsible forces. There are the four types of the forces is responsible for generating the winds, creating the winds. One is the pressure gradient force, then geographic or the Coriolis force, centrifugal force or cyclotropic force, then frictional force. So what is the Coriolis force? This force comes to play due to the rotation of Earth. Earth is rotating in own axis is called as the, and creating the force is called as the Coriolis force. So the air particles cannot move in a straight line but are deflected and move in curvilinear path because of the Coriolis force. And in northern hemisphere, wind moves towards the right due to the Coriolis force, and in southern hemisphere moves toward the left. At equator, Coriolis force is near about 0 or equal to 0, but increase regularly toward the pole. As going toward the poles, the Coriolis force is increasing. Then centrifugal force. When there is marked curvature in the isobars. Isobars means the equal pressures points or line of joining the equal pressure on a meteorological graph. The curvature in the isobars, a third force, that is the centrifugal force. It acts outwards from center of any curve motion. Then frictional force. The frictional force is maximum at surface due to the geographical conditions, due to the earth or soil conditions. The frictional force is increasing or decreasing and gradually decreases with the height until it becomes insignificant. This decrease with height leads to clockwise change in wind direction, which is sometimes called as Ekman spiral. As increasing the height, decreasing its force, that is frictional force, and the direction of the wind is clockwise, and that phenomenon is called as the Ekman spiral. Geostropic wind. When the wind flows in a straight line with no acceleration or frictional force acting on it, the only forces acting are Coriolis force and pressure gradient force. Geostropic winds is nothing but our natural winds when it's a straight line, that is air, that is a wind with air in parallel to the earth surface with no acceleration or frictional forces is found, then that is a geostropic wind. When the acceleration or frictional force acting on the wind, that's called as the different types of the wind. So the wind flowing under this condition is called as the geostropic wind, and it blows parallel to the isobars with high pressure to right direction in the northern hemisphere. Its velocity is inversely proportional to the distance between the isobars. So graphically, you have seen here, this is a, suppose this is a one place and here is a year. With a stable year is there. So if the pressure gradient force and centrifugal force, this is the green line, centrifugal force, this is the pressure gradient force. These force are equal, then the geostropic winds is there. Means they are not applying any force on the atmosphere, then that is a real wind or geostropic winds. Already we have seen. If the low at the center means cyclonic condition, or the depression or pressure or deep depression has formed in the atmosphere, in that condition what happens? The pressure gradient force is stronger than the centrifugal force. And here you have seen what happens. I'm explaining here. You see from the start. Suppose this is a point where the pressure gradient Coriolis force is equal, then geostropic wind. When centrifugal force is applied, it's moving upwards, and the pressure gradient force is stronger than the Coriolis force, then the low pressure is creating at the place, and depression or deep depression has found. Again, the cold condition is happened because of the here wind speed has going to compensate, then again it is coming to original position. In the second, here is the high pressure as the center is creating That is the anticyclonic condition. The same process is here when here is the pressure gradient force is more. Due to this, the cyclonic condition happens. Here is the Carlois force is stronger than the pressure gradient force, means here anticyclonic condition is formed. So these are the three forces: pressure gradient force, centrifugal force, and Carlois force is applying on the generation of the wind. It's okay? Any confusion?
So please explain it one more time.
Okay. So suppose this is a atmosphere at a particular place. Suppose this is a Badnapur. At Badnapur, atmospheric condition is stable. If the pressure gradient force is because of the, already I explained, due to the atmospheric pressure, and Carlois force due to the acceleration or due to the rotating of the earth, and centrifugal force due to the acceleration of the earth's center. Is it right? So pressure gradient force and Carlois force is centrifugal force is equal. Then wind is blowing, and that blowing wind is called as the geostropic wind. If the pressure gradient force is stronger than the centrifugal force, Carlois force, then what happened? The pressure is decreasing at this place. And what happening? The cyclonic condition in this way. This is the pictorial graph. Cyclonic condition is increasing. So wind is blowing this way, this direction, that is anti-clock direction. And due to this, the depression, deep depression, trough, cyclones has developed. If the pressure gradient force more increasing and increasing, then cyclonic condition is happening. Wind is blowing more speed. Then second phase, if here is suppose high, means pressure is high. What happening? Pressure is increased at this place. What happening? The Carlois force is stronger than the pressure gradient force, and wind is start to blowing clockwise. See this graph. This is the factor. This is the forces. No need to go in deep. We are not learning the meteorology or cloud physics. Just you understand, just you keep in mind the three forces, that is pressure gradient force, centrifugal force, and Carlois force, are responsible for generating the wind. And the second one, if the pressure gradient force and Carlois force is equal, then normal wind is there, geostropic wind is there. And the third one, if the pressure gradient force is stronger than the Carlois force, cyclonic condition or low pressure is generated. If Carlois force is stronger than the low pressure, then the anticyclonic condition is generated. Now, is that clear?
Yes, sir.
Okay.
Yes, sir.
Thank you. I also not be easy to teach online, because I am habitual to the offline. Offline teaching, face-to-face communication, and the speed of the proper wording, speed of the language, and the speaking is the different. I have not be much easy, and I'm not familiar to these online classes, so it is difficult to me also, like you. Okay. So general circulation, already we have seen the definition live. The more on the due to the heating of the Earth surface, that is incoming radiation and outgoing radiations. Balance is there, the heating is there. So we have seen at the equator more energy, and the pole is less energy. So at the pole, emitting radiation, that is the energy, heat is more than the absorb getting the energy. In the equator, more energy is conserving, and hence temperature is more. On the globally, there are different places, different type of the atmosphere, that is a cloud, rainfall, sunshine. Its heating is different, and due to this, the atmospheric circulation is found on the earth is called as the general circulation. So, and the atmospheric motion or the wind, when summarized over the earth's surface, is known as the general circulation. And how it is, the direction of these winds, we are going to see the general circulation of atmosphere or the earth's surface. There are the equator. These are the different sails. That is a polar sail, then mid-latitude sail, Hadley sail, and that is the intertropical convergence sail. This is a very important for the phenomenon of the tropical region of the world. So these are the wind pattern. That is wind pattern, horizontal wind pattern on the globally. That is a polar sail. This is a feral sail, and it is a Hadley sail. So both, this is in a north hemisphere, this is a in the southern hemisphere. Hadley sail, feral sail. So direction, in the equator there is a temperature is high, pressure is low, and water content is more due to the evaporation and these things less, and therefore the pressure is low. So what happened? The from the Tropic of Capricorn and Tropic of Cancer, the wind is blowing toward the east side. So there is called as the trade winds. There is northeast trade winds, and this is a southwest trade winds. This is a trade winds. Then doldrums, गर्जनारे 40, जिसको हम कहते हैं. So it is in the feral sail. So again here is the pressure is high, and what happening? This is toward the toward the west side. This is called as the westerlies. And the polar easterlies. Again at the pole there is a pressure is high, that is going to the eastern side, and it is called as the polar easterlies. So these are the wind patterns on the earth surface, on the earth or the earth atmosphere. So if you ask in the examination, describe the wind patterns on the earth surface, then you sketch the diagram and give the explanation of different these types of the winds. Then classification of wind: vertical current, horizontal. So the air is moving toward the parallel to the earth surface is called as the horizontal, is called as the wind, and vertical moving of the air is called as the current. Basically, difference should be understand what is wind. Wind in motion horizontally and wind in motion vertically. That is current, and this is the wind. Okay. So in the vertical current, divergence, that is in the anticyclone, convergence is the cyclone, eddies, and convection. These are the four types of the vertical currents. Then horizontal wind, there are again three types, that is periodic monsoon winds. Then general circulation, we have seen trade winds, westerlies, polar easterlies. Then local winds. So horizontally, that is the periodic, general circulation, local winds. In the periodic monsoon, south east monsoon, then northeast monsoon. Southeast monsoon means बरसात का दिन जो है मौसम. And trade winds, westerlies, polar easterlies. Local winds, land and sea breeze, mountain and valley breeze, foehn and chico winds, and tornadoes. We are not need according to our syllabus to see in deep about the classification. Okay. Then instruments. I have the another two, but it's ready. This is a cup counter anemometer. This is the in observatory, and this is the wind measuring the wind speed, and this is cup counter anemometer called as, and it is the measuring the wind direction. Some digital instrument is there. Also, be some instruments which are measuring the direction and speed in the automatic weather station. So role of wind is very important in the agriculture. If the 1 to 11 kilometer per 1 or less than 1 kilometer hour, this is not useful the agriculture purpose, because this is not useful to the photosynthesis reaction, and pest and disease is more. Then 1 to 5 is 1 to 5 is useful. Then 6 to 11 kilometer per hour is also the useful, but it increasing and the somewhat extent the evapotranspiration. 12 to 19 is not too much useful, but not a too much. Uh, it is useful to for the spreading of the disease, and there are some disease pest as reducing the pest population also, and more than the 20 to 28 kilometer per hour as a disaster to the agriculture purpose. I am not going to see here in much detail. We are going to see in the role of the microclimate. In that, we are going to see, with the references and some reviews. So, what is the mean by windrows? Windrows is a pictorial representation, wind direction and wind speed. So, this is the windrows. This is a pictorial, the average wind. It may be for the one day, for the 1 hour, for the 1 month, for the 1 year, for the 10 years, some wise. According to requirement, we can be calculating the wind speed. How much speed? This is given the speed here. Different colors has given the speed per hour, and direction, and which direction, how much percentage is given. The wind is blowing in which direction. These are basically the direction are four: north, south, east, west. Then sub direction: northwest, northeast, then east, southeast, then southwest. Then again sub direction is the north, northeast. Likewise, the 16 direction is there in the meteorology, and according to that, the graph pictorial representation of the speed along with the direction is called as the windrows. So another picture of the windrows of the Mumbai for the period 1 January 2017 to 31st January 21. This is a 1 month average wind speed and the direction observed in the Mumbai. Then this is the graphical again representation. What is the speed of the wind? Here is seen different color and found on the different region of India. So this is some articles I will share, already shared with you for a ready reference and for understanding the concept of the wind and its uses and the role of the wind in agricultural production. Oh, thank you. Any question? Anything else remaining? You want to know, or you have to add in the lecture? Already I told, I am also getting the difficulties to conduct the lecture, to deliver the content because of this online education. Anybody? Yes, please. Top share, can I? Yes. सो गए क्या सब लोग?